Good morning and welcome to our last lesson in Unit 12. This is a lesson on combinations. So yesterday we looked at permutations and we talked about how to find them. So reminder that we looked at the long way of rewriting all the different ways that we can write the word girl. But there's actually a better way to do this. It's to use factorials. And so we're going to use a factorial here. There are 1, 2, 3, 4 letters in girl. So we're going to do 4 factorial. So we're going to have 4 times 3 times 2 times 1. And that would give us 24. Now, for the word boy, there's 3 letters. So we're going to do 3 factorial. And we get 3 times 2 times 1. And that's 6. So that's just a quick refresher on how to do permutations. So let's do a little bit of an intro. You're packing to go on the middle school retreat and you lay out your 4 favorite t-shirts. One is blue, one is yellow, one is green, and one is red. But you only have space to take 2 t-shirts. Write all of the possible permutations. So we know how to calculate the possible permutations. We did that yesterday. But today we're going to practice writing them all out again. And we're only taking 2, so I could take blue and yellow. I could take blue and green. I could take blue and red. Then I could take yellow and blue. I could take yellow and green, yellow, red, green, blue, green, yellow, green, red, and then red, blue, red, yellow, and red, green. So there are all of the possible permutations. And we know that we have 4 options, but we're only taking 2. So we're not doing 4 factorial completely. We're doing just the first part of it. We're doing 4 times 3, which would be 12. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is correct. So how many permutations are there? We just said 12. Cross out the groups that contain the same letters. For example, blue and yellow, yellow and blue. Okay, we can do that. So here we've got blue and yellow. Here's yellow and blue. We've got blue and green. Here's green and blue. Those are the same. Blue and red. Those are the same. Yellow and green. Green and yellow. Yellow and red. Red and yellow. Green and red. Red and green. So why do you think we would cross these out? Well, if someone says, which shirts did you pack? And you say blue and yellow. And they say, oh, don't you mean you're yellow and blue? You'd be like, that's the same thing. Blue and yellow and blue are the same combination of t-shirts. And this is what we're talking about today. So with permutations, we're looking at all the different ways we can rewrite them. But combinations, we see that there are actually only 1, 2, 3, 4, 5, 6 combinations. Because yellow and blue and yellow are the same. So a combination is a grouping of orders in which the order of the objects does not matter. So again, saying, are you taking your blue and yellow shirt or your yellow and blue shirt? It doesn't matter what order you say them in. Whereas permutations, the order does matter. So in our intro, the total number of permutations for 4 t-shirts taken at a time is 4 times 3. The number of the smaller group, 2 t-shirts, is 2 times 1. Sorry, I just had to make a change because I realized it said combinations here instead of permutations. But the number of permutations of the smaller group, the 2 shirts, that you're taking on the retreat with you is 2 times 1. So to find the number of combinations, we need to take the total number of permutations over the number of permutations of the smaller group. So in our example, that would mean that to find combinations of t-shirts, I'm going to put of shirts, it would be the total number of permutations, which was 4, over the number of permutations of the smaller group, or how many t-shirts are we taking with us. And so this is going to be 4 factorial, and this is going to be 2 factorial. So we're going to have 4 times 3 times 2 times 1. all over 2 times 1. Well, this would give us 24 over 2, which would equal 12. And if we look back, oops, we had oh, I made a mistake. Sorry, team. It's not 4 factorial proper. It's the 4 times 3 because we're only taking 2 shirts. That was my mistake. So 12 times 2, which gives us 6. So remember that here I made the mistake of the total number of permutations does not mean that we're always doing 4 factorial. It means that we are just taking how many permutations of the shirts in this case. I'll fix this on another slide, and we'll practice this together. So a box contains 5 colored pencils. How many different combinations of 5 pencils can be chosen from it? So we need the total number of permutations. So we start with 5. Remember, we're not going to do 5 factorial because we're not rearranging all 5 pencils. We're only rearranging 3 of them. So we're going to only choose 3 values. So 5 times 4 times 3 all over. And then it's over the number of permutations of the smaller group. Well, 3 is the smaller group. So that would be 3 times 2 times 1. Well, up here, this would give me 60 over 6, so I would get 10. If you want to check your math, 5 times 4 is 20. 20 times 3 is 60. 3 times 2, 6. And then divide, and we get 10. So there are 10 different combinations. And again, that's saying like maybe you have red, orange, and yellow. A permutation would be saying red, orange, yellow, orange, red. Oh wait, that's all of the red first. I could have yellow, then orange, then red, etc. Whereas a combination is saying, I picked these 3 colors and it doesn't matter what order I picked them in. Combinations will always be less than permutations. So a bank allows its customers to create a 4-digit PIN code for their account, but the customers are not allowed to repeat any digits. How many different combinations of PIN codes are available to choose from? Well, let's think about what digits are available. You've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because if you get to 10, you're using 2 digits at the same time. So how many combinations are available to choose from? So for the first digit, they have to fill in 4 of them. There are 10 options here. Don't fall into the trap of saying, oh, 1 through 9, so there's 9. This 0 adds a 10th digit, so there are 10 options to choose from. But then they've used 1 digit, so now there's only 9 available. And then 8, and then 7. And we're going to stop there. I don't care about what comes after because they're not making a PIN code that's bigger than 7. They're making one that, or bigger than 4. They're making one that is exactly 4 digits long. So we're going to have 10 times 9 times 8 times 7. And we're going to say all of this goes over, actually let me do this, the smaller permutation, which would be saying that there are 4 digits. So we would be doing 4 times 3 times 2 times 1. And the number in the denominator is always going to be a true factorial, where we're going all the way down to 1. The numerator is not a true factorial because we're not going 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We're stopping in this case at 7. On the previous one, we stopped at 3, but this was 3 factorial. So the denominator should always be a factorial. So if I multiply all of these together, I am going to get 5,040 for my numerator, and I'm going to get 24 for my denominator. And I'm using my calculator for this. I'm going to divide 5,040 divided by 24, which equals 210. So there are 210 combinations. Notice that the bigger the values that we're using, like for example 10 versus 3, this number is going to get a lot bigger, and so are our combinations. The difference between them is going to keep growing. All right, try this one and pause the video and then come back and check your work. So we need to take the 22 presenters, and in the numerator, we're going to fill in 5 blanks. For the first presenter, you have 22 options to fill in. for your second slot, you've already gone to one presenter, so you've got 21 left. Then 20, 19, and 18. I've got 1, 2, 3, 4, 5 values. In my denominator, I'm going to use my smaller value, factorial. So 5, 4, 3, 2, 1, all multiplied together. When I do that math, I get 3,160,080 over 120. And then dividing those two, I get 26,334. All right, I've got one more for you to try. Give it a try, and then we will check your work. So he has 12 job offers. He must be quite the employee. And he's going to work 2 jobs, so he can choose from 12 for his first job and 11 from his second job. And then we divide by the factorial of the smaller number, which is 2. So we get 132 over 2, which is 66. Here's a little tip for you. This number should always be a whole number. If you get a decimal, you have done something incorrect. It should always be whole. It should always be positive. You should never get a negative number. I was typing a number in my calculation in my calculator, and I got like 20. It was on this one. I got like 26,300.66666 repeating, and that tells me that I did something wrong. So I rechecked my calculations, made sure that I was typing things incorrectly. So always get a whole number here because you can't have part of a combination. So head on over to Google Classroom and check out your assignment for today. And as always, let me know if you have any questions.